product engineering, software architecture and consulting, product management, team building, and mentoring. He have extensive experience in advanced analytics like machine learning and data science, big data technologies like data lake, lakehouse configurations, business intelligence, and data governance. He worked closely with various levels of management for devising statements of project, estimation, planning schedules, risk assessment, and impact analysis of project lifecycle. He have experience of leading Snowflake Center of Excellence team within organization for multifaceted innovations, research and development to serve customers better and build a strong foundation with product engineering team. Mr. Shishir sir works on different technologies like Snowflake, Amazon AWS, Microsoft Azure, Tableau, Oracle OBE, Informatic BDM, Oracle SQL, performance tuning, business intelligence, and etc. Presently, Shishir Srivastav sir worked as a senior manager at Tech System Global Services USA. I welcome you, sir. I request Shishir Srivastav sir to please proceed, sir.
Thank you very much, Annaji sir. Thanks for the dignitaries who are here. I did attend one of the initial session for a few initial minutes, although it was pretty late, so I dropped out early. But then a little bit spent a little bit of time in a couple of days and just watching through two different sessions and seminar. It was very interesting topic, although you guys have chosen, and especially on a very difficult times, it's very interesting to work on such technologies. In fact, the organization with which I'm working, basically they are pretty engaged with a lot of healthcare organizations and medical manufacturing equipment companies, and we are building various applications on that, helping them grow, at least to deliver things faster. So probably could be my area of interest, and I'll take it from there. And I see a lot of my colleagues, my ex-colleagues, Maludi sir, Walson sir. I see Sandeep Ganorkar sir. I worked very closely with him earlier. So I see a lot of folks and very, very interesting time. Let me share my screen and take it from there on. Let me know if you guys are able to see my screen.
Yes, sir, it's visible.
All right. So the topic which I chose, basically the digital transformation approaches to enable communities fight COVID-19 pandemic. So the reason to go for this topic is, of course, this whole faculty development program is basically devised on a topic of COVID-19, the pandemic which is going on, and how do we deal with it? At least we are in the field of information technology or software engineering, and how can we fix this whole problem, at least from our side, from our perspective, at least with the help of digital technology and armed with digital technology. So that's why the topic of today, which I chose, is basically digital transformation, because that's a buzzword in industry. And why it is a buzzword, probably I'll explain it later. So the agenda, of course, as a software developer, I grew from a small software developer. From there on, all the way to leading a product company as a project leader, and from there on moved on to becoming a manager, and then looking after for the whole software development lifecycle. So I tend to take all the problems which comes to me, in a software development cycle manner. Talking about this particular session is also on the similar lines. I'll take that as a software development cycle. The way software development cycle has been done, we choose what are the requirements, the customer requirements, and then we go from there to design, development, basically, and then implementation and support, and eventually to maintenance and support of the project. So that's basically a usual development life cycle. And I would like to take this whole session in the same approach. So that's why, the first bullet point which you see is what is COVID-19 disease. Although pretty much everyone knows it, what COVID-19 disease, but I just want to reiterate what exactly is the problem and how can we deal with the same problem with the arms or ammunition which we have, the software technology or information technology, the knowledge of it. How can we, leverage that in the next section of technology thrust? We talk about that. The role of data. The role of data is, of course, is critical nowadays, and it will be critical for dealing with COVID-19. That's the only thread I see which we can pick it up and keep building on. What is a digital transformation? That's the next topic. Why I picked up that name of this presentation, and then from there on, going a little further into technical details of what exactly is a descriptive analytics, predictive analytics, and prescriptive analytics. Which will definitely go in detail, and then a use case of how weaving all these technologies together and making a fabric of a technology sort, or maybe an ecosystem which can deliver a perfect solution for this pandemic situation. But let's not forget about the ethical concerns, which pretty much always in the news. You might have heard a lot about that. You might be reading in the news recently about Aadhaar card and all that. So wherever there is a data, there are ethical concerns as well. And then finally, we'll take some question and answer from you. So moving on, let's talk about what is COVID-19. So the basics are pretty much known. It's not something unknown thing. We are talking about COVID-19 is basically a disease, came from mainland China, or I would say Wuhan. It's also called as mainland China, from Hubei state. And the form of the disease is basically already known. If you can ask me, or the amount of reading I've done, the background of this is basically a SARS syndrome. So a severe acute respiratory syndrome. Basically, that virus is being known for a long time, but it's a new genetically modified form of virus, which you can call it as SARS-CoV-2. And why do we call it as COVID? Because it's named after coronavirus disease of 2019. So it's originated all the way from there, and it has got symptoms or the behavioral things of previous SARS virus. So that's why it's been named as SARS-CoV-19. From there, it's been a widespread disease because of certain attributes it has got, like high transmissibility. It transmits pretty fast. Fatality rate. Although I gone through the before preparing this slide deck, I was going through different articles and reading about what is SARS-2, COVID-2, or COVID-19. What exactly are the facts or the numbers about it? And although I figured out, it is fatality rate says that greater than 1%, but there are a lot of claims by different scientists which says that it goes well beyond 2% or even 3%. The numbers looks pretty small, but if you see globally, with the amount of population our country has, the amount of population across the globe has, and if you take out that percentage from the whole population, we are talking about a huge number. So that's the reason it's been called as pandemic, and it's a viral spread disease, and there's no cure for it so far. At least the numbers which I see, I tracked. It seems 5,65,000 deaths have already been done, and that damage has already been done by COVID-19. So it's basically a dreaded situation, not something to be proud about or not something to deal with it. But there are different mitigation measures suggested by scientists who are working on this basically disease. Although there is no cure for it, but the amount of uh, issues it has, or the uh, symptoms it generates, basically to figure out, are we actually suffering from COVID-19. There are basic signs or symptoms which we all know. The fever, cough, and shortness of breath. Basically, that's a key point, I would say, which tells you where the problem is. So there are certain symptoms which are little different than other diseases of SARS, like influenza. That also has similar symptoms, but shortness of breath and things like that, it is not there. So a common cold and flu, the way it spreads, the similar way this disease is also spreading. It's basically spreading because of human contact with each other. As far as I know, in India at least, it came from Middle Eastern countries. People have traveled from all the way there to Kerala. I read about some Italian tourists came to Rajasthan. So that's how at least it entered uh, in India. But then, if we follow the chronology of this, how it has been spread, uh, China is the main source from where it has actually spread across the globe. So, moving on. Um, Usual precautionary measures. So I want to emphasize on some of the things here for this session, because it's very tightly integrated with the solution which software industry is offering uh, to people across the globe. Basically, we as a people coming from a digital world, we don't have any say in this pandemic, other than providing help based on whatever knowledge we have. We cannot produce medicine. We don't have any way, or the knowledge or the expertise to have vaccine for this whole disease. So what we have, the things which we can do to help uh, cure this pandemic is basically some of the things which are already known and can be made known to public upfront beforehand. That way we can help control this disease. So precautionary measures, we're talking about personal hygiene, of course, and then exposure to public and crowded places. That's very critical point, because although, as I said just now, the numbers in US itself are growing pretty rapidly. They are the number one in the world. The reason for that is it's very simple. People are not wearing masks, coming out in public, and there are multiple reasons. The things which are happening around. So how do we deal with this? How do we deal with this whole problem, and what can we do from our side as a technology uh, people, people with the knowledge of software industry? So a thrust which we can give it, push, maybe a thrust which we can give it from our side, which can help us to deal with this whole problem. Um, so what are the basic areas where we can help and control this whole disease? So you can see a digital technology at the heart of uh, this whole technology thrust. I picked up some of the points, and the heart of it is our digital technology and ourself, the people, and how to empower people, how to enable them to deal with this whole problem. So a digital technology and the pandemic preparedness, that's the heart of it. And then there are a lot of areas where as a digital technology, this whole thing can be dealt with. Contact tracing, uh, quarantine and self-isolation, that's one of the things. Of course, people are taking care of, quarantining themselves, self-isolating, but how can a digital technology help them to identify that they are the actual perpetrator, or they are the actual people who are suffering, or the potential patient of this disease. Similarly, I'm talking about screening for infection. What are the measures across the globe different countries are taking to screen for this infection? Clinical management, how doctors are taking care or dealing with this problem, and what software technology is helping, how software technology is helping them to prepare for it. Planning and tracking, and eventually the medical supplies. So all this, and then going beyond, the different technology parameters which are across the globe are helping to deal with this. Like contact tracing is GPS driven. Similarly, quarantine and self isolation is artificial intelligence driven. Like how there are cases where countries, they are leveraging their technology power and helping people across their country, or the citizens of those countries can use those technologies and move on. So these are some of the buzzwords which we can talk about. So what is contact tracing? So there are two ways with which we can deal with contact tracing. It's one of the empowered way of dealing with this pandemic. It's a solution, I would say, a simple solution, which is being offered by technology people, or the specialist of pandemic who deal with this. They have suggested that if a person is infected, if you know the boundary of his infection, and if you know who all are in contact with him or her, and if you all quarantine all of them, then we can still contain the problem. And they had succeeded earlier as well in 2014 with Ebola virus, and a similar SARS outbreak, which was SARS-CoV-1. We are talking this as COVID-2, CoV-2 basically, that's CoV-1. So in that was during 2003 and happened in Africa, African countries, and it was contained uh, um, uh, in initial stages itself through contact tracing. So how do countries are dealing with it? So there are countries, South Korea, New Zealand, they have contained it completely, and they have enabled people through manual process, or maybe talking to people explicitly and telling them, if you are in proximity of any patient, we can identify you and bring you, to an isolation. That's one. But what if you feel that suddenly one fine day you start sneezing, short of breath, and all those symptoms, if you feel, you want to go and touch your family members? Of course not. uh, you might want some sort of technology, call someone, doctor, tell him all the details. So those kind of patterns, technology people have identified. And one of the major technology company, a couple of major technology company I was talking about, and I put it down here, is Apple and Google. They came up upgrading their iOS, Android, and iOS, the corresponding operating system of their mobile phones. They have provided this solution that bringing in a common platform so that phones can talk to each other. You really don't have to keep telling. Assuming you have some kind of app installed on your mobile phone, your app can talk to some other app which is maybe within a distance of 6 feet or 5 feet, sitting next to you. So that's one of the technology, although it has got a lot of implications as well. And sorry, people are skeptical about whether we should go for that or not because of of course security reasons. On the similar lines, India has also introduced Arogya Setu app. They're also that's one of the form of contact tracing. How does it work? Basically, it's a Bluetooth technology. It's a Bluetooth technology, whereas a key is being generated, um, and that key is being shared across different phones if they are within the range of potential patient. The primary requirement or mandatory thing for this whole thing is you need to have that app so that you can store your information and say that yes, I am a COVID patient. So if you are, then of course you can share the data if you want, if you wish to. And the moment you wish to share the data, it generates basically a key, and that data transformation happens. At least with Apple and Android, they made sure the information which is shared is just that little information that hey, the person next to you is might be a COVID patient or potential COVID patient. So that's one of the contact tracing problem, and that's how the technology is working hand in hand to deal with this problem. So how they are getting ready with all of this is they are creating common standard protocol, because Android is written in its own assembly language, iOS has its own language. How do they talk to each other? They have created a standard common protocol so that they can talk to each other, share the information. um, and you need to have health app to share the data, as I said. And this whole information is basically shared with the help of Bluetooth. So that's about contact tracing. Now let's talk about quarantine and self-isolation. Um, so what is the major reason the organizations or the companies or the policymakers basically they are coming up with different uh, different solutions to deal with this problem? We had in our country major lockdowns. There are other countries as well who had faced a similar problem. How can technology be leveraged to isolate certain set of patients who are potentially patients or can be potentially patients in future? If they are, if you just quarantine them, isolate them, you can let rest of your population can go across your and do all the work which is needed for them, essential work they can do. And there are a lot of examples other countries have done. In as I said, in Hong Kong, they have created a wristband with which you can identify if a person who is a COVID-19 patient. So they maintain a database and they give a wristband to the patient so that they can roam around. I mean, when they roam around, people across who come across them, they will get notified. Some kind of alert mechanism. Similarly, Iceland, they have a mobile app which lets people know that it is a person was in self isolation for some time, so it can give you a red alert right away. Similarly, you have numerous example about China's quick response code system, which talks about a survey of the system across different communities. They go and do a survey that how many patients were observed in this particular locality or community. Based on the density of the data, they alert people, hey, if you are traveling to that place, be very, very careful. That could be potentially dangerous, and things like that. Similarly, on Taiwan, they are using phone-based GPS tracking system, which lets people to to know whether they are potentially in hazardous place or not. So it's different technology. Similarly, on South Korea, they have apps to identify who are the potential patients. One of the other areas of interest is screening for infection, which where technology is being used very heavily. How it can be used is to contain the virus. So, of course, we know the virus spread is happening because people are coming in contact with each other. Um, and if a potential patient goes and being a close proximity of group of people or a single person, it can immediately spread that. And it does not, it's not inborn. It is basically infectious disease, as we all know. So how to contain those hotspot? So in US, there are a lot of measures they are taking through digital thermometers. They are frisking people so that they can go ahead and quickly figure out who all are infectious people and how can we contain them through real-time data. In Iceland is a pretty small country, although they have done a tremendous job while controlling this whole pandemic. They are using a lot of investment in clinical research, genomic sequencing of data, and bringing all of that data, aggregating all of that data and putting it to the mobile technology so that they can share all of that information with their citizens. Web-based tool like cloud-based technology through which we can create AI kind of solution or solutions of infection based on the areas where it has hotspots. I'll come to that in later in the session when we talk about descriptive analytics. But we all know there's one site which I think globally people are following, World Meter. I think that's one of the site which people are accessing quite frequently to get the data of how many infected people across the globe are country-wise, the numbers, how the numbers are increasing. So that's how screening is being leveraged to contain this problem. Now talking about the clinical management, how clinical management is being leveraged for empowering citizens or community or societies to deal with this. Um, we know clinical management is a specialty area of doctors. And how can we help doctors? How can we help healthcare workers? So there are technology scans have come up, AI-based computerized tomography scan, which in common language we call it as CT scan. It helps. What they are doing is, they are engaging that technology with the tool or the CT scan, get the data. And if you have certain symptoms which are different than the regular patients, then you are immediately identified as, hey, this person is a potential hazard or can be a potential patient of COVID-19. Let's not, help him to deal with this whole problem. So things like that, AI-based solution. And then there is COVIDnet. If you can go and Google about COVIDnet, it's an open source uh, uh, code, which if you put the details about your health data, or and it can aggregate all of that data based on their data modeling, and can help organization to figure out, whether a patient can become COVID-19 sooner or later because of the symptoms or because of its behavioral problems. So That's one of the technology that can be leveraged. And machine learning algorithms, that's pretty common across the globe, although I picked up a China example because that's they have done it pretty successfully in their in their country. And then virtual care platform. So because healthcare workers are the first responders, they are the ones who are dealing with patient on and off on regular basis. So how can they be helped? Can a patient or can a doctor sitting at a remote place, not getting in contact with the patient, do the treatment? A virtual care platform, digital monitoring through video conferences. Can that be done so that they can, at least they can be made safe in this whole chaotic situation? Um, Planning and tracking. That's another area. So planning and tracking is again, a data-driven awareness campaign where uh, um, different countries they are capturing the data. They are capturing the data and aggregating it in number of ways, so that they can alert their people. That hey, if you go to this city or this locality, or if you're traveling from this place to the other place, and if you come across this particular place, be very very careful. That place is actually heavily infected. That's a red zone. Why don't you take this green zone, which does not have any uh, uh, potential patients of pandemic or COVID-19. Similarly, machine learning models, which are helping and uh, predicting the areas or the potential patients, how it can be done. Maybe we can talk about that in detail a little later when we go talk about prescriptive and descriptive analytics. Um, uh, Again, one of the best example to deal with this problem is Taiwan. Taiwan, they are containing their travel of the people who are coming from coming into their country from across the globe. They are doing initial scans, and they are the initial country who have started all of this. And because of them, I think they are the pioneers. Probably, I would suggest they are the ones who have started all of this. That you have to push initial screening at least at all the entry points of your country. And they've started with Wuhan, and I believe they have the lowest death rate. Of course, the country is pretty small, and the number of entry points are also very less. So containing that is easier for them compared to the large countries like America or China or probably India. But there are measures which technology companies have taken to deal with this. And then, of course, data dashboards, which I just spoke about, Worldometer, which is providing a dashboard of how many people are infected, what are the areas, and what are the recoveries. We have to see the positive side of this instead of looking only at the negative. And then Upcode, a company or organization which is helping Singapore Ministry of Health to provide locate the data about the potential patients of COVID-19. And lastly, medical supplies. So this is the area I would say it's not directly helping. I would say it's a case of B2C in if I use the term of finance. It's basically it's not a B2C where I can when I'm talking about creating a solution directly to the consumers of or it's they are not the real consumers who are benefiting from the software technology, but they are B2Bs, basically business to business kind of scenario where technologies are helping them to manufacture PPs, personal protective equipment. How can that be built with a lot of pace? What data can be shared with them so that, you know, hey, if you are facing certain kind of problem, in this region where you see a lot of potential of spread of this virus, do you really have inventory of PPE equipment there? If you don't, you see that as a potential hub sooner or later. Why can't we supply or why can't we replenish our stock of PPE upfront? You know, similarly, helping the healthcare scientists to create a database of genomics. The topic of this whole discussion, is about optimization, and where we are talking about optimization, AI, and ML. It's all about data. It's all about how the data is being played around, and how can it be cut through to make you help through this complete situation. So how can healthcare scientists can break that genomics or that protein of COVID-19 virus, which can be broken so that you can quickly reach to maybe a medicine, or I would say a vaccine, right? So that kind of help we can provide, and it's being provided. It's being provided by different large organizations who are working on this area. Then data-driven heat maps, which I already spoke about, and then providing all the support which is needed to staff through ventilators and PPEs and all kind of resources. So with that, it what I wanted to highlight here is basically what exactly was the role of this pandemic, what havoc it is causing across the globe, and what different countries are doing it to contain it, and what is the role of technology which is being played. In all of that, in all of the 6 pointers which I spoke in my previous slide, is all about data. So if you notice, that's the common thread in that. We were talking about data either through heat maps, either providing genomics data, or giving manufacturing companies, empowering them with different kind of um, details about how they can manufacture things pretty faster, or how can they build their own ventilators, things like that. So it's all hovering, or all covered around data. Now, the role of data is becoming very, very critical these days, and now we'll see in further slide how it is becoming critical in future. So what exactly is data? When we say role of data, and what exactly are we talking about in terms of data? Data is basically collection of facts. So and I'll talk about that in few other slides. Uh, there are eminent personalities and the scientists, or the people who have worked in this industry for many years, and I don't have to explain that to the people who are in this panel. Everyone knows what is the role of data, basically. But just to put in context, it's been there with us since ages, whether in the form of textbooks, or in the form of accounting books. We do Diwali puja, or the business people, they maintain their journals, accounting journals. Through ages, it's been coming along with us. But it started to take shape when birth of computer have happened. So people have started putting all of the data into the computers, and then because of faster, of course, faster computing power, and that has all been leveraged, or that has all been I would say supported because of relational database system. Now things have moved on from there, because initially relational databases provided the backbone to the data industry, capturing all of the data, and you just fire the queries on the database, and you can get the relevance of what sort of information you're looking for. So you can capture all of that. through transactional processing systems. Um, and it is being, so far till today, it is helping organization for decision making, and it will remain there. It has its own a niche. It has carved its niche in the industry, and it will remain in future to help organization. Although there are a lot of innovations are happening around it, and I'll talk about that when we see a framework of data ecosystem. We'll talk about that. But then new form of data is coming these days. We're talking about data coming from web pages, data coming from sensors, data coming from mobile phones or social platforms. People are tweeting, Instagram, Facebook. There are multiple ways data is coming, and it's coming very thick and fast. It's humongous and it's growing pretty fast. So uh, um, so far in I would say traditional ways, way back, I would say around 2005 or somewhere around 2010, uh, organizations were completely devoted to pull up the data through database system, a relational database system. But when the data started flowing in this form, where web pages, sensor data, sorry, and social platform, this kind of data is started to capture. It become pretty difficult. But then there are innovations, because necessity is mother of all inventions, as we say. um, it has actually propelled whole of this exercise to come up with new technologies. And the pioneers, as we know, Google, Microsoft, or we talk about Oracle, and there are so many startups who have invested. And how can I forget open source community? Apache Software Foundation. They have Hadoop. We talk about Spark, and like there are hundreds of different technologies, and we can keep swimming in that ocean of technology, and we will still be figuring out ourselves that hey, I wasn't aware of this whole thing. So this basically gave birth to data science, a new stream of research, which they call it as data science, where how do you find the patterns in the data? How do we deal with this multi-varied type of data, where the data is coming very thick and fast through velocity, different quality and volume? So there are different aspects that needs to be studied. That's basically the role of data. And you can see I've put down some of the key quotes from industry leaders who have worked on that, like Clive Humby. He is basically data scientist from UK, an engineer who's pioneer of some of the technologies, and he coined this term, "Data is the new oil." And we've been hearing it quite along with you guys. You might have also heard about this, that data is the new oil. And because why they are putting that analogy of oil here, because so far oil is the one which was generating money across the globe. Now technology is driving, and the technology is uh, harnessing the power of data. So data is at the center of the growth, and data is pushing next revolution. When I say next revolution, we're talking about climate change. The climate change is happening, and then there are solar energy is coming, wind energy we are talking about, and all of that. New technology. We are at the cusp of industrial revolution, and scientists are talking about AI. They're talking about machine learning, and all of that. And it is going to see very soon. I'm working closely. One of the organization back there in Bay Area, the true Silicon Valley, where I've got some of the friends who are working in Yahoo, which is part of Verizon now, but I have friends in Facebook, Google, and they are part of Google Brain project. They're part of AI project. And what I hear from them, they are moving pretty thick and fast. They are moving.
Sorry to disturb you in between. Actually,
Sorry,
some of the queries are posted by the participant in the chat box.
sorry. Okay. How do I access that? Okay. Yeah, so I see is the accuracy of MLDL model depends on the data volume. Of course, no. Uh, I mean, I would say to an extent, yes, and to an extent, no as well. Why it is like that? If you don't have data in the volume which is needed, you will never be able to give the exact prediction. So we'll go to that in detail when we talk about prescriptive and descriptive analytics. Uh, am I not? Um, are you guys not seeing my PPT? I see that someone is saying that Dr. DG Anand saying share the PPTs. Looks like I don't. He's not able to see the PPT. Is that what the question is?
No, he is actually expecting you to send the PPT separately
Oh,
once
I
the
see. I see. Okay. Okay. All right. Okay. Yeah. Yeah. Sure. Yeah. So that's about data. Let's talk about digital transformation. So digital transformation is again a new area, and that's the area which has taken the whole world by storm. When I say by storm means it has actually changed the perspective of how business has been done. It's a radical approach in the sense. I'll be coming to an example in the next slide, but it's a complete paradigm shift. We organizations are moving from technologies, the I would say old technologies to the new technologies. The technologies we're talking about, the cloud technologies, AI and ML, which is a theme of this talk. So people are moving, and the organizations are putting a lot of push towards that. And how we can, I can take an example of Amazon. Just think of it, a company which started as a bookseller. You know, they started their initial business or their initial business model was selling books when the growth of internet was pretty rapid back in 1990s, early 1990s. Jeff Bezos, he invested all of that, his energy, money, and knowledge into Amazon and started book selling business. But where they are now, that whole the start of the business and where they are now is a complete paradigm shift. They started with the book selling business and they are now industry leader in lot many ways at different places. So that's basically a reason of digital transformation. They moved on from what their initial business is, and they put a lot of I would say uh, uh, thrust to their business model to keep changing, keep reinventing, and all of that. It's all of that because of the data. So they kept on, pushing that data, studying that data. The data is actually, I read very funny, or I would say more than funny. It is very vital or a key quote. It says. Uh, an ounce of data is worth than 1,000 ounce of opinions. So you will see there are marketing wizards, there are MBAs, and there are thinkers in industry who can tell you how to run businesses, but their knowledge is completely based on their experiences, which I'm not saying it's completely wrong. I'm not denying that. But if you are armed with the data, this whole thing can change to help you grow. Um, and these days, all the different industries. It's not about one particular industry of software. It's about political organizations. Social organization. You talk about healthcare, talk about manufacturing, telecom companies, everything, even the educational institution. Right now, we are having uh, um, uh, this whole webinar, or I would say this talk of faculty development program through a Zoom call. It's a completely paradigm shift. Nobody would have thought a few years back, but now it's becoming possible, and we are enforced to do it. So in a way, pandemic is pushing us to think in through a new technology. And I just mentioned, a couple of examples. As I said, Amazon, where they started, and you take an example of Uber. They have taken the taxi business completely out of context. They are growing pretty fast. If we don't change according to technology, we will suffer sooner or later. So that's a basically paradigm shift, and which is happening because of the digital transformation which is happening across the globe. And that's why I wanted to bring this topic here of digital transformation, because digital transformation has pushed this pandemic to, or maybe I would say in other way around, this pandemic has pushed the digital transformation to go to a next level. It has expedited this whole process. So there are several examples like that. We can talk about that. Like I can basically keep talking, giving example and talking about the history of all those, and hours and hours. It will never end. But the gist of it is basically digital transformation is revolutionizing the whole industry, the whole world, I would say. Now let's go a little deeper into the technology. So how this data, once now we know about data, we know about COVID-19, we know about you guys have heard or heard from me a lot about digital transformation as well. How this is coming together, and how are we leveraging that to help this, or to deal with this pandemic situation. Let's talk about different uh, in a way, I would say, approaches of dealing with the data. Data in traditional ways, data was dealt with. You just get the data, you process it, and once you process it, just show it to your different departments. If I go back maybe before 2010, the usual way of running industry was you just pull up the data from maybe let me explain this in a better way through a manufacturing company. So let's say a manufacturing company, if they are developing different manufacturing equipment. So what they do, you have a supply chain department, you have a manufacturing department, you have an inventory department, you have planners, so different departments. And a procurement department, basically you raise the request, you get whatever thing you need it in your organization. You pull that raw material, process it, manufacture maybe a car or whatever, let's say a ventilator or personal protection equipment. All of that, it needs some kind of raw material, it needs procurement, it needs supply chain. So these things, they were running earlier in silos. And with the revolution of new technologies, things are changing. Now they are no more in silos. How? We'll talk about that a little later. So what exactly is descriptive analytics? That's one of the form of data, and which I was talking about, before 2010. Uh, Data was mainly dealt with descriptive analytics. I would say descriptive analytics, when I say descriptive analytics, it is a form of insight which can give business an answer like what has happened. When I say what has happened, I meant to say you have data, you play around with it, and you will get only one set of answer, that what has happened. Like I've got, for example, I've got uh, take an example of this healthcare industry, Worldometer. You can go back, you can go and if you search on the site, it can tell you how many patients were identified in India. Especially, I don't know if they provide drill down to a level of cities in India, but I know at least till the state. So how many patients are identified in Maharashtra, right? We are in Maharashtra and we are worried about that. So how many patients have identified since yesterday, day before yesterday, from 1 week, from past 1 month? How is the growth? So what has happened? That kind of questions are answered through descriptive analytics. How we will talk about that in the next slide. So it's a traditional data warehousing approach where pull the data, process the data. So how do we pull the data? There are multiple sources of information available. So they process all of the data from multiple healthcare institutes. They pull the data from different hospitals. Did you get any new patient today? Did you identify any new potential patient which can be an active case? So they keep feeding in their computer system, and all of that is aggregated and pushed it into one data warehouse, and that data warehouse actually processes all of data, aggregates it, and shows it to you. So that's basically, we call it as descriptive analytics. I'm using these terms because I'm talking in front of academicians here, and these terms are more familiar to academicians than to the industry people. But yeah, so that's basically, I wanted to bring it here. And what it does, it processes the historical information and summarizes or creates an aggregated view of the data. So that's descriptive analytics, and it basically pulls the data from, as I said, pulls the data from multiple sources. You will have data coming from different hospitals, different healthcare institutions. That data, they capture it through a process of extracting all of the data, transforming it so that you all can see a uniformed or a layered data which can be compared as an apples to apples rather than apples to oranges. So they have to transform the data and load it at a centralized place so that reporting can be done on top of it. So that's basically a nature of ETL transformation, which they do it. And for that, you need certain references, like who are patients, what are the hospitals. Those are different data dimensional modeling components. So yeah, so this is one particular architectural diagram which I made it here. So you can just see it's a high level view of architecture of how a descriptive analytics works. So you got multiple source system. You talk about I've just named some of the leading ERP softwares who are used in most of the industries. You talk about healthcare, you talk about manufacturing, you talk about airlines. They either use one of these. Most of them, they use one of these ERPs. And once you get the data from all the ERPs, you just push that data into one of the staging table, and from there it gets pulled into to the next level where it gets processed, and you get into website over the internet. You can create your own reports if you are a super user. You can download that Excel sheet. You can get the alerts on mobile. So these are some of the examples of, or I would say, an architectural view of descriptive analytics. I don't want to go too much in details here, but it basically the same thing which I said. It pulls up the data from multiple sources. And the diagram which I mentioned here, the previous slide, it was mainly about different sources, but now those different sources can be enhanced. We can talk about uh, inserting the data of Instagram. We can talk about inserting the data of Facebook, Twitter, where people are feeding continuous data that, hey, I found my neighbor infected. Someone tweeted about that, and just some kind of information around that. You can just suck up that data, bring it into your system, and just tell your users that, hey, there is a potential patient coming in this locality. So that kind of information, which is unstructured data. I gave an example in earlier slide was about structured data coming from the relational databases, but unstructured data in different file formats like flat files. We're talking about different file formats like JSON file format and all other things which are Parquet. The Apache Software Foundation came up with uh, a compressed data format. So I'm using a little bit of technical words, but I believe no one would be uncomfortable with that. But going ahead with that information, so that information gets processed on nightly basis. Usual way of handling this whole data, is I would say traditional way. The organizations, they track all of the data, pull it into their system on nightly basis so that the users who are accessing those reports or the data should not see, a performance, a drop in their performance. That suddenly you click on something and you wait for hours or minutes, and that what the hell is happening? I don't see my report. That kind of issues being resolved if you keep pushing, data on nightly basis, so that users who are sleeping during that time, you can process your data and bring it up into the fore. So that's descriptive analytics. Coming to predictive analytics, that's the area where we are talking a lot these days. So what is predictive analytics? It is a branch of data science where we are talking about data and plus statistics. So it goes a little step further. We got the answer of what happened in descriptive analytics. In predictive analytics, we can give the answer of what happened plus when will it happen. That kind of extra set of information can also be provided. And I think someone has asked that question that can it be done through small set of data. So I would just want to bring up that question, that it is really difficult. It will not give you a true information about nature of data unless you have a really humongous data set. I'm talking about a data set which is of the size of terabytes, maybe 100 terabytes, 200 terabytes, or even at the size of petabytes. Yesterday, I was talking to. I'm sorry. I just joined for a few minutes and then I dropped off. I was listening to the other talk by Dr. I think Umesh Deshpande sir, and he was talking about optimization. He was talking. I didn't go in the details, but I just heard he was talking about N-Queen's problem, and it's a typical example of predictive analytics. I would say if I have to use that as the example here, and I just use that example as is that N-Queen's problem deals with you are playing a chess and you wanted to see, we call it as game theory. You want to see what is your next move of your opponent. So if you play, if you move your pawn to the next level, what all possible moves an opponent can play around with it. So all of that data, permutations, combination, all that comes with the statistics. And if you capture and if you keep that algorithm of the statistical algorithm there, you can definitely predict all of the data. Just to give you an example on how predictive analytics on a layman's term, if I have to go, that let's say people are dealing with stock market, or in the context here, people are suffering of COVID-19. Now we are almost 4 or 5 months, maybe I would say, after this pandemic has happened. Now we know the nature of behavior or the behavior of this virus. and how people are dealing with it. Some people are staying back at home. Some people are literally roaming out without mask and all that. So if you keep collecting all of the data, and at certain location this has happened, maybe we are talking about Ebola in 2014, or in 2003 the SARS COVID-1 has happened. So if we know the pattern of the data, that how it has happened earlier, probably we can use that same model, data model, and place it. You just have to place that model and just keep feeding this data. It can give you a predictive data set, and can tell you, hey, these are the regions where it can be a potential hazard. You might see some kind of risk at this particular place if you don't control it on that particular community. It can help policymakers, governments, agencies, healthcare workers, hospitals. Hospitals can get ready that they've known the past behavior of any kind of disease in their area, and they know that people start rushing in their hospitals, so they can get ready ahead of time. So things like these that can definitely help predictive analytics after we model it. So and it can help in predicting based on the large data set. Of course, it needs a large data set. And the technology, mainly we are talking about Hadoop and Spark, although um, uh, it's an end of era of Hadoop. You might Google it and see people are saying Hadoop is the end of Hadoop. I kind of disagree and agree with it, because Hadoop is as the cloud technology has came in, Hadoop is little going away, where people can do it on their own rather than it's pretty easy to go on cloud and do things. But Spark is pretty much alive, and it's helping machine learning language with their libraries to help devise different data modeling algorithms. Sorry. And to process all of the data, you need to have log files, images. I mean, you don't need to have, basically, it has the ability to process different data types of videos and audios. You can process basically video data. If you Google about Netflix, how they are suggesting to their audiences that what movie you may like. So it's basically a machine learning algorithm. They have placed it based on the behavior of their audiences, what kind of movies they are liking it, they are choosing it, what kind of movies they're watching it in between, and then just dropping off, just after 5 minutes. So that kind of pattern, they are identifying it and using it for this purpose. Yeah, so these are the modeling techniques. You need to collect the data. We can collect the data, clean the data. Why I'm saying cleaning the data, because if you're pulling the data from Twitter, if you're pulling the data from Facebook, or even if you're pulling the data from your organizational transaction system, right? Uh, there are data entry operators who can make typing mistakes. They can put wrong purchase amount. They can enter wrong information by mistake. Someone is a non-COVID patient, they can mark them as a COVID patient by mistake. It's a human error. It can happen. So you have to clean up that anomalies. You have to remove those outliers, make the data clean, talk to the business, the frontline workers who are there. I'm just speaking for that one particular example. And then once the data is cleansed, you can put the different predictive models. There are different, I mean, just it's a vast area of study. Predictive modeling, we are talking about hundreds and hundreds of different algorithms. To name a few, like linear regression, multiple regression, and things like that. There are various regression model, forest regression, data capture mechanisms. So all those modeling techniques, they are using it to create. I mean, I'm talking about they means data scientists. They are using it to create machine learning algorithms. There are supervised, unsupervised learnings as well. Okay, so This is a typical modeling technique which is being used in in predictive analytics, where we are accessing the data. You just capture all of the data, process it. Process it. Data reduction. Data reduction means, because we're talking about terabytes of data, you get you generate heat maps and you see different flashes of data. So all of the data, you can reduce it to a size so that you can actually process it and put it in your development model. Once you create the model, you can leverage that model, and you can predict what sort of solution you want. So all this job is basically of data scientists and data engineers who are working on this kind of technology. And then comes the prescriptive analytics. So this evaluation or evolution, I would say not evaluation, evolution is happening between analytics in three broad categories, although there are multiple categories as well. Now I see people are talking about cognitive analytics and things like that, which are although very specific and specialized, but they are, if you go a little above hierarchy, they are pretty much falling in this bucket of prescriptive analytics. So it's again, in descriptive we were talking about data. In predictive, we were talking about data plus statistics. If you add data plus statistics plus operations research, I think you everyone knows about operations research. It's a problem solving method where you can give an optimal way. So in yesterday's talk itself, I think Sir was talking about optimization. So how can you use that optimization technique and apply it on machine learning? Basically, if you do that, you're coming up with prescriptive analytics. It's the base of artificial intelligence. Along with it, you need to feed the business rules, set up the boundaries that okay, my business is only talking about, or if I speak particularly about healthcare workers. So let's talk only about hospitals. Let's talk only about healthcare workers. Let's talk only about patients. Let's not talk about who are my suppliers are, because I want to alert my patients that you might be in potential danger because of the health hazards you have. So you need to lay down the boundary of the data, what you need. That is called as feature selection. Basically, we select the data and just remove unnecessary sort of data from there and proceed from there on. And of course, it needs special skills, as I mentioned here, data scientist and data engineering team. Okay, I just want to quickly run through, because in the interest of time, probably I'll be a little faster here. COVID-19 solution. We can use different artificial intelligence based genome sequencing or ribonucleic acid protein study. That kind of data, if we provide to the virologist or the scientist, they can quickly come up to a solution. They can quickly get the vaccine, which is much needed right now, or a medicine. So that kind of data we can help to expedite through prescriptive analytics. Here is the evolution I was talking about. I just picked up this diagram from Gartner. That's one of the leading industry who works on the data. And that's how you get the answer. You need to choose what level of investment you want to do in your industry. If you just want, what happened with my data, what kind of reporting you need. You want to go to next level, which is basically it's part of diagnostic analytics, is also part of descriptive analytics, as I said. If you want to go to the next level, which is predictive analytics, we are talking about area of research where you want to predict, where my customers are in future. What are the potential areas where I can find patients? Prescriptive analytics, where you give the answers as well, not only what will happen, what can be done. It can give you solution as well along with prediction. So because of the power of optimization through the operation research. So that's pretty much about analytics. Typical use case, just want to show one architectural diagram of how this all being laid out. It's pretty complicated, and there are a lot of different technology names you see. Data science lab is being set up, and we are talking about a little bit Databricks, Kofax, then Microsoft Azure. That's a cloud technology where you want to host all of your data. Then you see, structured and semi-structured data. This is the branch of data where it's coming to sensors, machine sensors, or maybe Twitter, Facebook, things like that. And then you want to store all of that data, process it through some kind of an engine. This is a data integration engine, which is Boomi. It's owned by Dell. And then you push it into, some of larger warehouses. One of the upcoming technologies in the cloud is data warehousing on Snowflake. If you want to go ahead and read about it, they are the leading data solution providers these days. So you just compile all of the data flows from all of this, and you push it there, and then sorry, through analytical tools you can report it. Power BI, you've got Tableau, you've got R language, and then Databricks. It's one of the companies which is providing machine learning solutions or Spark solution, Spark based solution. So that's it. And then the last thing which I wanted to talk about, in among all of that, where we were talking about data, there are ethical risks as well. Although all these solutions and everything looks good, but the problem is very severe. Why I'm saying severe is, what if a doctor has got medicine for 5 vaccine, or maybe medicine for 5 patient, and you've got 10 patient in front of you, and you have to give it to only 5. How can you deal with such situation? That kind of thing has actually happened in Italy. I was reading one of the article. So when the numbers were too high and doctors were not able to decide who to treat first, so that's where this whole thing comes, that stay back at home, don't go and expose yourself in such hazardous situation. So there is unfair discrimination which doctors can do, or anybody. Forget about doctors. We talk about manufacturing industry. You do if you get too much of data about them, you start negotiating with your suppliers. Start dealing with your customers through unfair means. Reinforcement of human biases. Quickly, just to give an example of that is. We don't want to discriminate people based on their caste or their creed, their religion, their color of skin, from which region they are coming from, which country they belong. So that should not happen. These are some of the ethical concerns are coming because you are capturing the data, and when you capture the data, you capture their location, your age, your date of birth, from where you belong, and all of that data. Once it comes into picture, the person who's doing the data modeling, the person who's doing the predictive modeling or the AI modeling, they can insert those biases, and they can make the choices to the consumers or to users. They can only see favoring certain set of people. That kind of thing. That is reinforcement of human biases. Lack of transparency, because we're talking about petabytes of data. It's very difficult for data scientists to to justify that why they have cropped certain amount of data. As I was talking about data outliers which are bad, which can give you in a different direction of data. So such kind of bad data, they want to crop it. If you crop a true data and you don't put it somewhere in your documentation, that basically creates problems. So that kind of transparency, lack of transparency from data scientists or data engineers can create potential problems if we keep collecting the data. And of course, preserving the privacy. And we know all of that about recently I was reading about Arogya Setu app, And a lot of people have raised the concern, and eventually they made it open source. That's good of our government, because once it's open source, it's open to everyone. It's not lack of transparency. You are bringing it everyone to opening it up so that everyone knows about it. So things like that, those are actually ethical concerns are coming. And quickly, let me see if I have any questions. Yeah, it depends on data volume. As I said, it is not. I mean, of course, it is depend on data volume, but it needs a lot of data. Of course, not small. I would say small set of data. Any questions from anyone? I would be happy to answer, although it's a little late. I know I'm taking too much of your time. I wanted to speak more about that, the other things, but I spoke about things which shouldn't be, more interest of you guys, basically. um, Away. Okay. Any other question?
Hello.
Any question from?
Yeah,
Yes.
participant, if you have any questions, you can put your queries on chat. We'll wait for 2 minutes.
Yeah. Thank you. So I'm getting a compliment. It's very informative, although I don't think it is. It was. I was going through at a high level. Probably I would have been in more detail for the areas of topic which you might be interested in, like how the modeling is being done, or probably how the whole architecture flows through it. May I get the PPT? Yes, probably I'll send it across to Jaiswal sir, Malude sir, and probably they can share it with you guys.
Yeah, probably there is no query from any of the participant. So shall we move ahead?
Yep, that's all from me then. Thank you very much, sir.
Yeah. Thank you, sir. Kolte, sir, please proceed.
Yes, sir. I'm audible, sir.
Yeah.
Yeah, you are.
I think it is my privilege to present vote of thanks to such a great facility like you. On behalf of eFDP Organizing Committee, KDK College of Engineering, Nagpur, and Professor Roshan Kolte, Department of Information Technology, would like to express my heartfelt thanks to Mr. Shishir Srivastav, sir, who spared time from his busiest schedule. Today, we had an opportunity to hear your valuable thoughts, and this will surely be going to encourage all of us in future. Sir, you explained important concept, digital transformation approaches to enable communities fight COVID-19 pandemic, descriptive analytics, predictive analytics, prescriptive analysis, and many more topics you have covered. Your thought have enlightened our minds, and you have shown us a new path. Thank you, sir. Thank you very much, and thank to all the participants for joining us.
Thank you. Thanks a lot. Thanks for the opportunity.
Yeah, Shishir sir.
Yeah.
There was one question in chat box. Just now I received it. What hardware configuration required
For
for?
college level, for
Yeah.
data processing,
Yes.
I think, yeah, just a minute. I think my battery is getting down. Let me quickly switch to the other headphone. Are you guys able to hear me?
Yes, sir.
Yes, yes.
Yes.
Are you able to hear me, sir?
Yes,
Yes,
Shishir, you
yes.
are audible. You please go ahead.
Are you able to hear me, sir?
Yes, yes.
Yeah. So in terms of data, so for data, we have you get lot of data sets available in public domain. That is the data. But in terms of hardware, if you really want to see the hardware, I don't think it can be easily available because there are a lot of at academic level companies are offering cloud solutions that can be leveraged, but that may not be that much importance for you guys because once you get the crux of this whole thing is data. So there are public data sets which are available. Uh, uh, sorry. Hello. Hello.
Yes, yes.
Yeah. So there are public data sets which can be leveraged. Once you get the data, you might need to host it on a platform. Now that platform is a little tricky. I'm not too sure about for academic purpose how it can be leveraged, but I know there are uh, the cloud platforms like Amazon AWS or Azure or Google Cloud Platform. They're offering for the academic institutions with some some discounts or even free accounts even for individuals for a certain period of time for a month or so. So if you have a data, you can just host it up, and in fact on those cloud platforms also there are a lot of data is available. You can process all of that data, create your own workbooks. You might have seen the Kaggle. I don't know if you guys know about it or not. There's a community called Kaggle, which is a Google company. They provide a lot of competitions among students, and it is open source. Basically anybody can participate in that. Anybody can engage, and there you can create your own data models. You can learn from there, and it is for basically for researchers or for academicians. That's the place to go.
Yeah, Shishir, one more question was there.
Yeah.
What are other scopes of data science in medico-social field?
What are the scope of data science in the field of you said what is it?
Medico-social field.
Medico-social. Okay. Medico-social field. I believe it is about medical.
It's a blend
Uh,
of medical and social field, sir.
yeah.
Yeah.
So I think data science is touching every life, and it's not limited just to medical or social field. I would say it can be applied to I mean all the way through. I was talking about healthcare data. You can talk about AI or machine learning algorithms that can be applied on top of the huge amount of data which is collected from hospitals, huge amount of data collected from medical equipment manufacturers. All that data set, if we can process it and can come up with data science models which can be used for medico-social field, which we are basically looking for. Are we looking for any specific use case? Any other question?
I think there is no question now.
Yeah, I mean, if someone really want to spend on these technologies and want to read about it and play around with it, I would suggest there are immense material available on the internet, and probably the place to go is maybe Kaggle for CAN machines. You can go and see that there are a lot of competitions are happening for data science, for machine learning, and actually organizations are sponsoring. If you participate in there, you'll get $10,000, $15,000, $40,000. They are paying for it. It's not like a free of cost service. If you provide them certain solution, and I see a lot of people from India and across the globe. I mean, not just India, across the globe are participating in there, and they are taking that benefit of different model creation techniques and all that. So you can definitely leverage all of that.
Okay. Thank you very much, Shishir, for your
Thank you, sir.
presence and your expert talk. We really appreciate your input for this particular session. Thank you very much.
Thank you, sir. Thanks for inviting
Thank you, Shishir sir. Thank you so much.
Thanks, Malika sir. Thank you.
Thank you, sir. Thanks a lot.
Sir, we would love to listen to you in near future.
Sure.
Yeah.
For a longer time, at least.
Yes. Yes.
Yeah.
Once again, thank you so much.
Thank you, sir.
Thank you, sir. Thanks
Thank
a
you, sir.
lot.
Thank you, sir.
Bye.
It was
Bye. Have
really
a good
nice.
day.
Sir. Thanks, sir. Thanks.
Sure. Thank you.
Good night, in fact, sir.
Good night.
Good night.
Yeah. Have a good day.
Shishir.
Bye.
Bye.
Bye. Thank you.
Bye.
The next session will start at 11:30 a.m. After which